First of all, a very good afternoon to all of you for this special seminar, which has been organized jointly by the Indian National Academy of Engineers, INAE, and the Center of Excellence in Oil, Gas and Energy. And we are really delighted to host Professor G.D. Yadav for this seminar. Let me start by inviting Professor Yadav and Dr. Singh on the dais for the inauguration ceremony. Yeah, please. Yeah. So we have online also, we have audience who have joined through the link. I welcome all of them as well. So as you know from the email that was circulated, this event is organized, this seminar is organized jointly by INAE and COE OGA. And to begin with, first of all, I formally welcome both of them, and I'll request Dr. Singh to briefly tell us some background about this event and about INAE and how this seminar has been organized. So I request Dr. Singh to please.
Good afternoon. Warm welcome to our speaker, Professor G.D. Yadav, and Professor Sastry. I thank him for organizing this webinar, online webinar, jointly by the Mumbai local chapter of Indian National Academy of Engineering and COEG IIT Bombay. Now, the background of this kind of seminar is like this. See, basically, the Indian National Academy of Engineering has three wings. Basically, the fellows are from three wings: the academia, the industry, and the research organizations. Now, we have been interacting, and my colleague, Professor Kulkarni, is also here. He is co-convener of our committee. Professor Suparna, she is not here. She is also actively working in this. So we normally organize webinars, online webinars for the benefit of the participants, particularly students and other industry people, and also research organizations. Now, from the three wings, we find that there is good interaction between the academia and the research center, but there is very little interaction with the industry. Also, although some webinars have been arranged, some conclaves have been arranged, some last 2 years on defense production by L&T at Lonavala. But those are very few in number. So we wanted to have increased interaction with the industry. And first effort was made when we had one webinar by Professor Rajiv Pandya in ICT on these chemical parks. And following that, we had our general body meeting in April this year. And we had some brainstorming that how we should increase the interaction with the industry. And some topics were identified in which the hydrogen energy was on the top. And that's how we came to know that, yes, Professor G.D. Yadav must be the first speaker. So that is the background. And now there are some various topics identified, machine learning and some analytical instruments and climate change and things like that. So we'll in future host some seminars on webinars on these topics as well. And I will seek also opinion of experts on this, how to increase the interaction with the industry, because that is very, very important. So with this note, I welcome you again on behalf of INAE. And this is the first webinar this year, and hope we will have many more like this. And another important aspect of these webinars is that we want to have good interaction with the expert and the students, particularly the research students and the faculty members. So I think you can use this opportunity also to discuss with Professor Yadav formally, informally, anyway, as he likes. So welcome once again, and I think now we will begin the function.
Thank you, Dr. Singh. Thanks for this background information. So we'll now get into the main event, which is the lecture by Professor G.D. Yadav. Let me briefly introduce him before we start. Although, you know, frankly speaking, I don't think he needs any introduction. Most of us, I'm sure, know him very well. But let me still go ahead and do the honors. So Professor Yadav is a highly distinguished scientist in India, known for his contributions to sustainability, net zero, green hydrogen, decarbonization, waste to wealth, covering green chemistry, chemical engineering, energy engineering, biotechnology, and nanotechnology. He holds the titles of National Science Chair of Government of India and Emeritus Professor of Eminence and is a former Vice Chancellor of the Institute of Chemical Technology, Mumbai, which has campuses at 3 different places. ICT Mumbai, I'm sure all of us are aware of. Additionally, in Bhubaneswar and Jalna in Marathwada. And the 2 additional campuses that started were mainly driven through his initiative. The 2 additional campuses were created during his tenure and through funds to the tune of 18,000 crore. Apart from an engineering scientist, he is also an innovator with 134 patents, 551 science research papers, and has guided 113 PhD students, 153 masters, and 48 postdocs. Just before the lecture, I was actually discussing with him, I would like to know his secret of how, in spite of doing all these things, he still manages to supervise PhD students. He is still actively guiding students and actively involved in research, as well as in industrial consulting for the last several years. He has won several awards. Let me mention some of the important ones. First and foremost, obviously, he has been awarded Padma Shri in 2016 and was selected as the US National Academy of in the US National Academy of Engineers and the US National Academy of Inventors. He has been successfully consulting many industries and is one of the members of is an independent director on the boards of limited companies, including Godrej Industries, Clean S&T, Meghmani Organics, Bagaria Industries, and so on. He has also served on the board of Aarti Industries for 2 terms. His pioneering work in green hydrogen production and CO2 refineries is internationally acclaimed, with 3 companies currently pursuing commercialization. He is also a fellow of Indian Science and Engineering Academies and many other academies. He has also been awarded the Sastra CNR Rao Award and the Advantage India Chemical Conclave Award. He has served on many committees governed by Government of India, ICT, UGC, and so on. And he is now appointed as the chairman of the advisory committee of the Green Hydrogen Platform of Ministry for New and Renewable Energy, Government of India, which is quite relevant for considering today's talk. So there are many other things which I have skipped in the interest of time. So I formally welcome Professor Yadav. I request Dr. Singh to felicitate Dr. Yadav on behalf of the Center and INAE. Yeah, so with that, Professor Yadav, I hand it over to you. We look forward to your seminar.
Thank you very much, Professor Singh, Professor Kulkarni, Professor Shastri, and my friend, Professor Naik, among the audience, many others here. Thank you so much. So what I'm going to do is I'm going to entertain you for next hour or so. One of the things which we talk these days is net zero. But according to me, net zero is not the solution. Net negative is the solution. So with reference to that, I will give you some background things. Perhaps you know that the so-called Paris Agreement or Paris Accord of 2015, where 195 nations of the world decided that we should restrict the global temperature rise to less than 2 degrees C and particularly 1.5 degrees C, except United States, which did not sign it. So, the next year when Joe Biden came, he signed that so-called the climate summit in April 2021. What was the reason? The reason is very simple, but now our friend is here from United States, but that time they said that carbon should not be emitted, right? That was the idea. But Kamala Harris says exactly opposite now. She says fracking should be done. So why? That was the reason. The reason is before the pandemic began across the world in January 2020, the atmospheric concentration of CO2 was 410 ppm. And perhaps you know that during the entire year we were glued to the TV or at home. I did not leave my home for 2 years. I know that. It was a sad period. Only thing we were doing online lecturing, which was again a bad idea because nobody attended the lectures. Within a year, we added 2 ppm next year, January. And perhaps you also know, because you are from Halliburton, Houston, on a particular day, April 10, 2020, the price of crude oil was negative. And there were 7 fracking companies in Texas. We were going to, invest something like $7 billion. They said there is no scope of hydrocarbon industry, and so it is going to die. People were really worried, and the pundits in the business of energy said that unless the price of crude oil rises above $60 a barrel, there is nothing you can do. So you can see that was a shock. Now, but slowly things started recovering. Remember that time the crude oil refinery capacity was 97.4 million barrels a day. Now it is 103.5 million barrels a day. That means we are emitting more carbon dioxide in the atmosphere. So of course we see that. So in May 2022, it became 418 ppm. And this is the latest figure, October 14, 429. And a year before that, 418. 423 and rather 418. So you can see that we added 4.43 ppm. If that trend continues, the temperature of the globe will rise to 6 to 8 degrees Celsius by 2050. Of course, we will not be alive, but our future generation will not be. So which is a serious problem. And last year we emitted 36.8 gigatons, that is billion tons of carbon dioxide, which is a serious matter. So what is going to happen to the future? So, let us look at this situation a little closely. And this is what the CO2 budget, because we are given a budget. We said carbon dioxide should not be emitted and there is a limit. And we say the maximum is 200, gigatons maximum. Then that will be 1.5 degrees Celsius. Okay, that is what the literature says. Okay. That is from the start of 2024. Now they are predicting that will happen in next few years. It is not going to take that long. It will be much before 2050. And you see that there is a serious problem. Climate has changed, floods are occurring, droughts are there. We know that these are some of the typical examples of the Indian cities, and we in Mumbai know what is happening. We blame the municipality, but I can tell you that nobody can do anything. I was in Delhi in May for a government meeting, and I came out of the room, air-conditioned room, and I felt that somebody is dumping me in fire. It was so hot. And the reported temperature was 52 degrees Celsius. But our IMD said that the sensors were wrong. Everybody has a sensor in his hand, right? But they say it was wrong. Whatever be the temperature, that was very bad. And so what it means that if the temperature of the place where you are living right now goes up by 3 degrees Celsius, life will be unbearable. So whether you are living in a cold country or a hot country, 3 degrees Celsius is the one which is going to. So 3 degree rise will be very bad. And you can see that. This year, across the world, many cities, towns in USA suffering. And one of the places, this is a very interesting statistics. In the Death Valley, the name is Death Valley in California. Temperature was 56.7 degrees Celsius. And another, the Furnace Creek, 42.5. Morocco, 47.6. So we used to think going to Nagpur, Yogendra, was bad. Now you imagine what is going to happen. And multiple countries reported temperatures exceeding 50 degrees Celsius. That means we are in real danger. So if we want to develop technology, it should be developed yesterday, not even tomorrow. That is the real fact of matter. Okay. So at the same time, since we are worried about economics, like the politicians always talk about economics, I should also talk a little bit of economics. So Economic Times, the energy world, on 19 July, they reported that India has cut the import by 5% almost. That is good. If your import of crude is going down, that means, okay, we are not going to emit more carbon dioxide. However, India is going to boost the electronic sector to $500 billion. That means more carbon dioxide. And steel industry is a highly polluting industry. 1 ton of steel produces 2.38 tons of carbon dioxide. So if we want to surpass China, okay, right now China is number 1, 300 million tons. India is 136 million tons this year. And this we want to go to 300 million tons in 2030 and 500 million tons in 2050, because our population in 2050 will be 1.67 billion people. Huge population. So our energy needs, material needs, they are all going to grow exponentially. So this is where sustainability comes into picture. So how do we have a sustainable world with all these factors running against us? I always say that if one technology creates a problem, another technology must solve it. That is the history of technology. And so we should not be desperate. We should not be saying that, okay, that will be the end of the world. No, there is always a better day tomorrow. So what is that better day? So this is another interesting point, that the World Meteorological Organization, they reported, this was a wide news here last year, that the 1.5 degrees Celsius temperature rise, which we are supposed to have during the entire century, will be achieved sooner. And that is not far away. This will be in 2027. That means we are really in a bad situation. This was reported last year on 18th May. So many times, all the countries of the world, OECD's countries, developing countries, developed countries, still developing, lag behind countries, everybody is talking about net zero and sustainability. So what is the meaning of that? So one of the things is hydrogen technology. So I'm going to cover some of these hydrogen technologies. What is their significance in this net zero and sustainability? Then carbon dioxide has to be taken as a new oil, because we will not have any crude oil by 2050. Whatever crude oil we have will be either exhausted or it will be too expensive to produce by any means or technologies which we know right now. Okay, so that is another problem. So can carbon dioxide be the new oil? So carbon is there, so we can certainly go on coupling it. How do you do that? Decarbonization of the economy is everybody's talking it. Anywhere you open any newspaper in the morning, some of these buzzwords are always there. Biomass valorization. If the crude oil is not there, what will be our source of chemicals, materials? It will be biomass. Waste biomass, purposely grown biomass. We will have all sorts of biomass. So how do we? And then another interesting problem is solid waste management. It has been talked as an ideal goal, that is zero waste society. Can we create a zero waste society? Suppose I say IIT campus should be zero waste. Can we do that? So that means our waste, right now the waste which is generated per capita is 1.617 kg per day per person across the world. So you can imagine how much waste we are generating. And municipal solid waste contains 50% of biomass, 10 to 12% of plastic, then debris, metal, all those things are there added to that. So solid waste management, waste plastic recycling. So, plastic has become a taboo. In fact, plastic was introduced as a substitute for paper. But the same plastic, so-called SUP, single-use plastic, we say, wait, don't have it. We banned it. India banned it. But it's a bad idea. I will tell you why it is a bad idea. Okay. So, and then water is a privilege, because we will require, and now somewhere there is drought, somewhere flood, but at the same time, there is no water inside the Mother Earth. So the aquifers are drying. So what do we do about that? And another word which is used, circular economy. And particularly chemical engineers are a lot of scope, I must tell you that. Because all the principles of chemical engineering can be used in this, where we want to, recycle things, materials, energy, whatever, we will do that. And of course, system engineering approach. We have to have systems engineering approach. So normally what happens, most of the sadhus, buas, bhavas, they talk about think positive. They say, think positive. I'm saying think negative. Exactly opposite. Of course, I'm joking. What I mean to say is that think of negative, okay? Think of negative, and that is what the negatives, carbon negative energy sources and material neutrality. Carbon should not be used as a source of energy. First thing to stop that, greenhouse gas emissions and, rise in temperature, global temperature rise, that can be stopped by using carbon negative sources. So obviously everybody knows about sustainable development. I can, split into three parts: societal, okay, and economic and environmental. One of the two important aspects decided by that SDG goals, 17 in number, that removing poverty and hunger by 2030, major goal, right? Then also we want to have climate change to be controlled, and also energy systems. And one of the most important goals here is goal number 9, which is industry, infrastructure, and innovation. Unless we have industries, we have adequate infrastructure, and we do, innovation, we have no future. Okay, that is what it is saying. Okay. Now you might have heard this term, and IITs are good at it. G20, everybody was asked to propose this idea. G20, Vasudhaiva Kutumbakam. But do you know really what is the meaning of Vasudhaiva Kutumbakam, which has come from Maha-Upanishad? Ayam nija paro veti ganana lagu chetasam udara charitanantu Vasudhaiva Kutumbakam. Meaning what? Normally we say this is mine, that is yours. But our philosophy said everything is ours. And we are going to be, we are already most populous nation. So we have to think of the world from that viewpoint, because we are going to be influencing the world's economy. So that is what it is, okay? So, so here, three terms are normally used. Bioeconomy, bio-based economy, circular economy, green economy, you can name anything. So I will tell you a little bit stories about all these three economies, what is meant by that. So, I gave a lecture to, this CII in Hyderabad, and I was telling them, because Ministry of Commerce and SEBI, because I serve on some companies as an independent director, I've been telling everybody that you should appoint a SID, SID. What is that SID? Now it has a Sanskrit connotation also in my ways, which is Siddha. It means Sustainability and Innovation Director. Every company must have this Sustainability and Innovation Director, because unless all stakeholders participate in that grand, goal, nothing is going to happen. Starts with children in the school. Even the class 4 employee must think that I am part of this whole system and I should think of sustainability. Okay, so this is, sustainability. Now, another thing is normally we talk about so-called things we are restricting ourselves, systems engineering. Even if I say I restrict myself to my process of production, okay, and I say, okay, I should not pollute. But no, there are others which are called scope 1 and scope 2 and scope 3. Something is coming by truck, maybe by railway, maybe by sea, maybe by air, okay, and something also being taken out of your premises because you produce that product. And that is also polluting. So when we talk about, sustainability, we have to think of all these three scopes. Okay, it is not just one. So you can imagine. So something which is, very nearby, you can just lift. But something which is coming by car or some truck or whatever, that is also adding to pollution. So nowadays, there are several seminars organized by many organizations. I'll address quite a few of them. This is called ESG. Environment, Social and Government Report. And all companies now are giving this. And unless they show that their carbon footprint had reduced, their stock value doesn't go up. Stock market is now looking at this ESG. It is looking at your carbon footprint, very interestingly. So this is the most important part, is environment. So environment and energy are connected, right? So climate change, biodiversity, water efficiency, energy efficiency, whatever you think of, whatever you studied. So in other words, we have to look at the environmental management. And one important part is also water. Water is going to be very scarce. So water is another issue there. So what it means that everybody from the top to the bottom, must be part of this sustainability goal. Everybody must think that I'm polluting the atmosphere, I'm adding to the pollution, so can I do something? So this is where our Prime Minister said this, a very famous term, Vikasit Bharat, which is accepted by English dictionary also. We want to be Vikasit at 2047. So my model is different. My model is we have to think of 2047 and say that we will be number one or number two. This will be our economy, $30 trillion or $45 trillion or $54 trillion. Various numbers have been thrown by economists. And then come back and change everything today. So whether it is Industry 4.0, 5.0 or 6.0, whatever, we have to think now. We have to change our method in which we educate our students, the manner in which we have startup companies. Everything has to be with reference to that Vikasit Bharat goal, okay? So you see what is happening in Vikasit Bharat. They say that unless our GDP grows at 25%, it is not going to happen. And that is a cumulative number. Then auto sector 10%, then capital goods 2.5%, 10% share in global professional services. Pharma will be one of the biggest revenue earners, okay? 500 billion. And we have to improve at the participation of ladies, women force. And that is what is meant by this Vikasit Bharat. But another interesting aspect, this slide is very interesting. When I'm talking about net zero, what they decided in 2015, only 73% of the countries have net zero goal. Others do not have it. Either they are poor, they are developing, or they don't have technology. Of course, they are less populated. In this particular case, in that 73%, 25% in China, 12% in United States, European Union is 7%, and 29% rest of the world, in which India is also included. Remember, and we are the most populous nation. So our carbon footprint will increase. That is why our Honorable Prime Minister said that by 2070, COP26 in Glasgow, he said that we will be net zero. That means net carbon dioxide emissions will be zero, okay? But really speaking, that is not going to happen. Why? Unless we change our attitude now only. We should not be dependent on 2070, but we said that 2045 we want to achieve it. Then we will change our policy. And in fact, there are good news. The good news is that most of the companies in India, they have set their own goals. Even a hydrocarbon company says that I will be net zero. Like Indian Oil says 2046 will be net zero. They are producing hydrocarbons, but they say will be net zero. That means whatever fuel they are making, that carbon dioxide they are going to take care of. In this particular sector, you see why I'm saying net negative. So India is number 4. We emit 2.622 billion dollars, rather billion tons or gigatons of carbon dioxide. And this has to be made zero. And we have to start today only. We have to start today. So how we do that? These are 3 different scenarios. If you want to say that is 36.8 or 4 gigatons, unless we bring down the emission to less than 10 gigatons a year, this is not going to happen. In other words, we should not be using any carbon at all. So that is what I'm title which I chose, Achieving Sustainability Net Negative. That is the reason. Because we cannot afford as a whole to have more than 10 gigatons, 10 billion tons. So that is the reality. So, so there are many sectors of decarbonization. We normally look at only transport sector. But shipping is one of the important things. 5% of carbon dioxide comes from shipping. Then the buildings and cities, you have air conditioning or you have to heat it in the cold nations, that is 35%. Then all other sections, including agriculture and industry, food and whatnot, okay? So so why it is happening? Because carbon is our major source. Our entire economy is based on carbon. And we realized that when the oil embargo was there. And in 1973-74, what happened? We were literally squeezed. Overnight, the crude oil barrel became $10, okay? So we can see that. So we already know fossil fuels, and another is the so-called renewable, okay, biomass. So now, typically the world's refineries have a ratio of fuel and chemicals, 70-30, okay? Now the things are changing. Now we are looking at carbon to chemicals, so coal to chemicals, or okay, so crude to chemicals, C to C. That kind of business is being talked about. So this is very important because of the carbon which we use in our fuel system. We have this problem. So how do you take care of this? So you can see this slide. There are two scenarios. One is the oil refinery, which you normally look at, where you produce variety of products, okay, and other this so-called biorefinery. So in the left side, whatever we do is greenhouse gas. If you use carbon as a fuel, it is CO2, okay. However, in the case of biorefinery, it is carbon neutral, and that is what they are talking about. They say we will have carbon neutrality by 2050, so-called net zero, okay. That is, so everything will be based on this biological carbon, okay. So this is where we have to have another issue. That is because we have only one earth. If we have the linear economy, we will require 3 earths. We require rare earths, we require metals, we require minerals, we require everything. For example, very recently we found lithium stock, but we have not got anything. There was a very big news of that. So we don't have lithium. We don't have many of the metals, precious metals. So material recycling is going to be a very big issue. And that means it is a rate process, chemical, physical, biological, including nuclear. If we increase the rate, we decrease the volume. That is what chemical engineering is talking about, right? So there is a tremendous scope for this. And another issue which we have not realized is that in the year 2000, we started this solar energy business and wind energy business. Now they have a life, typically a life of 20 to 25 years. All these solar panels are now available. They are dumped literally in millions of tons are lying. So what do we do? And they contain precious metals, they contain rare earths, they contain glass, they contain metals. Should we not be using them? So that is the part of the recycle. So you can see the solar panels, how they are lying. And it is solar energy only for limited hours. So now we have hybrid where solar and wind are combined together, and that is coming in India too. And the wind blades, some of these are composite blades. You will be surprised to know the length of this blade, 240 meters. They require the best of the magnets, okay? And so that material is available. And another is the battery, because when you have EV, we talk about electric vehicles, EV, and we are happy. But EV is CV, if the electricity is being produced by burning coal. That coal burning is happening somewhere else. In the city, you may not have pollution, but it's somewhere else it is happening. And that when the battery life goes to 80%, it is useless. It is useless. And that batteries are very heavy, you know that. So, but they have a second life, and that is storage batteries. So that is a very big business. China is number 1 in that. They have 9% growth in that business, and $45 billion business is there. United States is 6%. So I jokingly say Bhangarwalas will have better days. Because you collect any waste and sell it back into the market because you want that to be processed. So reprocessing of these used materials, whatever material is there, including the wood here, okay, for instance, we have to make use of that. So circular energy storage, and they said that 75% of this, electric vehicles, batteries can be recycled. So that is the future business. Believe me, EV will not have great business because EV will be only in small cities where there is infrastructure to charge the batteries. Long distances, batteries are very heavy. So it has to be hydrogen-driven cars, or other fuels like methanol, okay, or things like that. So another problem is the waste which is generated by municipal solid waste. Okay, wherever there is some stinking comes out, right? So it generates methane and carbon dioxide, H2S and whatnot. So that was 1.6 billion carbon CO2 equivalent. This will be 2.38 tons in 2050. That means that is also a major source of worry for carbon dioxide. And we know this. You cannot go to Delhi during December and January. The weather is always, the air quality index is above 500. You can't land there. You can't breathe also. Why? Because our farmers are well known for burning the agri-waste, which is, and you see that this is statistics provided by Times of India in one of these days. See how many people are burning sugarcane, cereals, pulses, oil seeds, whatever, because they think if they burn that the bugs will die. Carbon is needed in soil because it is a fertilizer. Carbon is needed for our survival, but carbon is not needed in the air. That is the major thing. So this is the regular thing. You go to north, these farmers are burning their wealth. So this air quality index, AQI, in Delhi is typically about 300 during those 3 months. And that is very bad for health. So it is not only, and so my suggestion is what? Farmers' income can be multiplied because our government always says, we want to increase the farmers' income. How? The best thing is ask them to collect this agro-biomass, which is very, very, bulk density is very low, compact it, densify it, make into pellets and transfer it somewhere else where it can be processed. And once again, hydrogen comes to be very big rescuer there. So instead of sugar factories, like we have cooperative sugar factories, we can have these kachara sugar factories, right? Waste to waste. That is, we collect all these agri-waste and make this. So that is very important, okay? So we have many of these things. So farmers, biomass cooperative societies must be established because they will get additional income. It depends whether they get 7 rupees a kilo or 10 rupees a kilo, because that is a very valuable source of chemicals. And I will tell you which chemicals. Another issue which we have, the plastic waste, PET bottle, for instance. You see this everywhere, and the rat pickers don't collect the plastic, pouch. They collect only this. Why? Because India is the only country which is perhaps this recycling of PET, where we also done some work, depolymerization and things like that. That is maximum 90% of this, that PET bottle. But that does not happen in the case of that pouch. And that is why that single-use plastic government has banned, but it is allowed in certain industries, food industry, for example. Why it is not done? Because that goes as a waste. And then we have all these problems, microplastic, this and that. Again, our government is wrong. I tell you why. Because supposing there was a deposit, refundable deposit on that plastic bottle, 30 rupees or 20 rupees per se, irrespective of size, weight, whatever, straw will be 20 or 30 rupees, bottle will be that, and the thin pouch of milk will be that. You have this barcode, okay? So housewives are very well known for taking every single drop of that milk from that pouch. They will shake it, clean. And 80% of our problem in municipal solid waste segregation is that. 80% cost is on segregation. Remaining on the technology. Then you say, I will generate energy, I will say depolymerize. But the segregated plastic which is available at home, like in the morning, some boy comes, gives in newspaper. Housewife will never throw that. She will collect the raddi because the raddi is more valuable than the content in that, right? So she will sell it and get money. If she is also advised, separate your pouch and give it back to somebody, another boy who comes, we generate employment. Digital economy. So you transfer. That boy will take some 5% commission. We will stop pollution. Single-use plastic ban is a bad idea because of that. Because in future, when we don't have any crude oil, this plastic will be a very big source of hydrocarbons. And I will show you a little bit later. Another issue, when you think free is not appreciated, you know that. You go to any marriage party, you have all sorts of dishes, from one end to another of the world, Thai, Chinese, Malaysian, Punjabi, Gujarati, Marathi, whatever you say, it is there. And they make it so attractive, you are tempted to eat it. So you take a big plate and take everything on the plate because it is free. But supposing there was another bowl there and it said, sir or madam, if you like that dish, put 100 rupees there. I can assure you that your wife will not allow you to touch it because she knows you are not eating at home. Because it is free, you are tempted to take more and waste it. That is how the 50% food waste is coming from that. That free idea is a bad idea. And at the end of the marriage ceremony, collect all that money from the bowls and give to the husband and wife, They will be very happy because they are getting money. Jokes apart, this is a fact because why plastic pollution? Because it was a substitute for paper. The plastic became thinner and thinner and thinner, stronger and stronger and stronger. So practically it costs nothing. Therefore, everybody is giving free. And they say 50 micron. Are you going with the micro gauge to measure 50 micron? How do you know 50 micron? These all, and so that is why the authorities make money on that, police and otherwise. Another important issue, because this is also related to hydrogen, because hydrogen requires water, nice quality water. So water management is going to be a big problem. Industrial water management is another big problem. So we have many, many technologies, whether you do desalination, RO, or this or that, water is important because 1 ton of hydrogen requires 9 tons of water. Okay, we require 9. So that water management is another issue. So if you look at the world's energy scenario, it is predicted by 2050, 73% of the energy will come from renewables. In 2050, there will not be any crude oil to be used for any of these processes, including refineries or all. That will be zero, okay? Several reasons. And in that time, it will be 49,000 terawatt hours. That is the energy required for the world. Hopefully, you know, it may go down, but that is what it is. I've been advising the government that we should produce 20% of this. 10 terawatt hours. Why? Because we can become an energy exporting nation. So we have to plan for water because water is required. If you want to use solar energy, wind energy, we have to have land. So why not use railway tracks? About that, you have this. Why not have combination of wind and solar so that because green means the energy has to be renewable energy. So that is what is required in this doing so. So I call, you know, this is my new trinity, like Brahma, Vishnu, Mahesh, solar energy, wind energy, and hydrogen energy. I call this as a new trinity. And I give prime importance to hydrogen. I call it as prime Devas. Devas is a Sanskrit word meaning deity. Why? Because solar energy and wind energy do not give me materials, fuels, chemicals. Hydrogen gives this. So hydrogen is a prime source. So, and you see I will not sing the praises of hydrogen. There are many things which are known to you, but one of the important things is that it has the highest energy density in comparison with anything traditionally used, whether it is wood or even ethanol or petrol, diesel, LPG, name it. And you can have clean energy from that. You can use IC engines, 2-wheelers, 3-wheelers, 4-wheelers. Okay, hydrogen can be used to make green ammonia because ammonia requires lesser pressure, okay, 10 atmosphere as against some 700 atmospheres or 350 atmospheres. So you can see that hydrogen is going to be a very important source, and that is going to be the Trata, the savior of the world. I call hydrogen as the savior. Now there are 3 different agencies which are predicted for hydrogen economy, and everybody is adopting that. These 3 agencies say that any numbers, they vary. That is not important. What is important is that in future, hydrogen is going to rule the world. So we must be ready with hydrogen technologies. So whether you have, you know, International Energy Agency, Hydrogen Council based in Europe, or Energy Transition Commission rather. So we see that hydrogen is very, very important. Now, so we did some thermodynamic analysis in my laboratory because we have been working in hydrogen for so many years. So we found that even if we assume 100% efficiency of the electrolyzer, the cost required to produce 1 kilo of hydrogen is $2.61, and nothing is 100%. That efficiency is lower. So the cost of hydrogen by electrolyzers will never be less than $3.5, even if you have the best of the technology. So everybody across the world is working on electrolyzers. Even if you get free electricity, the cost of electricity is going down, but in India particularly. So at the same time, you see what is the world's capacity. Today it is 120 million metric tons. Almost 1/3 of this hydrogen is used by refineries because there are 8 processes in refineries where hydrogen is required. So hydrogenation, hydrogenolysis, these are very important catalytic reactions. So we can have different types of reactors, you know, multi-phase reactors, name it. Everything can be there. 1/3 goes to that. And so as far as this is concerned, you know, and what is the electrolyzer? Almost 50 units it requires. So even the cost of electricity is 2 rupees or 3 rupees. You imagine just the electricity cost is so much. So in other words, hydrogen production from electrolyzers is going to be an expensive affair and it has to be scaled up. So how do we do that? So, I'll just introduce, perhaps that is what is called a green hydrogen, blue hydrogen, and gray hydrogen. Green hydrogen means water splitting, gold standard, use green energy, solar, wind, geothermal, hydro, whatever, including nuclear. Okay. On the contrary, blue hydrogen means that right now they do it in refineries. They take methane, natural gas, steam reforming, catalytic reaction, 700, 800 degrees Celsius. 1 ton of hydrogen produces 11 tons of carbon dioxide. That is gray hydrogen. If you capture 90% of that carbon dioxide, store, do whatever CCU as people talk about that. So that means it is blue hydrogen because but the capture requires money, right? So that is what it is. And there is another called, turquoise hydrogen. That is you do pyrolysis of methane, produce carbon and hydrogen. That is turquoise hydrogen. That is supposed to be better than the other two, but yes. But something else happened last year, that is white hydrogen. They found deposits of hydrogen, natural hydrogen. So you have to go into the history of formation of the deposits. That means it must have naturally been pyrolyzed like the turquoise hydrogen and it is stored. But that number is not, it is anywhere between 6 million to 250 million metric tons. And Mali was the place where it was found. Now everybody is looking for that kind of hydrogen and it is supposedly will cost less than $2. A delivery cost is different, okay? This is what it is. But at the same time, our MNRE, what they did, now I'm associated with them, what they said that, hey, okay, we should give incentive to our people. So even if you produce 2 kilo of carbon dioxide per kilo of hydrogen, it is green. So I said, don't change the definition. You can give incentive. It's like changing Avogadro's number because you don't like it. Right? Science you cannot change. You can give incentive to people, but not change the definition scientifically. So they had a discussion. We have a Indo-German, task force also. There, the German fellows say, no, we don't agree with you. Okay, so that is it. So hydrogen can be produced by many different ideas. And I'm not going into the details of any technology. I'm just giving you glimpses of this. There are many, many technologies of hydrogen production, but one which people normally talk about is electrolysis. Okay, and I already told you that the red ones, we have done many of this work in our laboratories. We have got patents also, but they all contain, they are carbon containing. So hydrogen, so steam reforming means more hydrogen comes from the water part of it, and the carbon is going with that, oxygen, okay, CO2. That is what is happening. But most of the people talk about electrolyzers. So we said, is it a good idea? Okay, so, and what are the problems in electrolyzers? Electrolyzers have many problems. One of the problems is, these are the main productions like anion exchange, proton exchange, and alkaline electrolyzers. The problem is the current density, the electrolytes, the efficiency, the catalyst, the membranes. Therefore, electrolyzers are not becoming cheaper. The cost of green hydrogen produced by electrolyzers is not less than $7 to $8 at a higher scale, not ordinary scale, okay? So that is very expensive. So you can produce from hydrogen from biomass, and this is one of the things the government of India is also promoting. Wherever there is biomass, whether it is sewage or foliage or whatever, you can make use of it, produce hydrogen. Once again, water comes into play, right? So that also can be done. So our, lignin cellulose with biomass. For example, the sugar factories, normally what they do, they isolate cellulose, hemicellulose. Now you can ferment, make ethanol. That is normal practice. But what do they do with the lignin? They burn. It's a cogen process. And that is used to generate energy. But that's also not a good idea. I'm telling that. That is a very important source of chemicals and materials. So we can do this lignin. So you can see that how many things can be made from this using this feedstock, whether it is oxidation or carbon dioxide reaction or water, steam, whatever. You can make this gasification of biomass. And there are many plants established in India where they do gasification. Okay, through DST, we gave some money to one of the agents. And there is another called, so-called, torrefaction. Torrefaction is that solid, you make solid. This is normally done for biomass, which is coming from, say, food waste, and the other back becomes hydrogen. So this is very important source. The food waste in the MSW is a very important source which can be used for making hydrogen. So at the same time, in our laboratory, we studied many things. We took all sorts of alcohols, bioalcohols, glycerol, ethylene glycol, butanol, N-butanol, particularly isopropanol, ethanol, methanol, to produce hydrogen. So again, these are catalytic processes. We have got patents, we have published also. But what is important is that we diverted our attention to something else, and that is thermochemical water splitting. Thermochemical water splitting. There are 310 reported cycles in the world. Many leading universities in the world and American, the Argonne National Lab and all, they are working in that area. So we also jumped into that. So initially worked on sulfur iodine cycle, okay? And later on we concentrated on copper chlorine cycle. And these are water splitting cycles. Remember, we got patents. For the first patent I got was in USA, then in Canada, then in Germany, then in UK, okay? The Korea, Japan. China did not give us patent. Everybody else gave us patent. So you can see that, so it is important that we can split water using thermochemical process. It's a closed loop, which we have been studying. We have a pilot plant in Goa. So meanwhile, what happened? Our Ministry of Power said, our aim is to reduce carbon dioxide by 45% by 2030. 50% of our energy will be renewable energy. So you be geared up, okay? What it means? It is water and air will be our feedstock. Split water, take nitrogen from air, either cryogenically or pressure swing adsorption. That nitrogen is coaxed with hydrogen, which is water, green hydrogen, then becomes green ammonia. Then you have green fertilizer industry. And ammonia can do the same thing as hydrogen can do. Okay, so this is what happens when you have green ammonia. Either you split it on the site of application, split it into nitrogen and hydrogen, use that hydrogen as green hydrogen, or burn it as such, like you do hydrogen. So only thing is you require a renewable source. So we developed this cycle called ICT, ONGC Energy Center. They are my partners. So we have developed this technology together and we're selling it. So I found that I can produce hydrogen in less than $1 in this. But there is a catch. Catch is that I have to have 100 tons per day. If I go for 1 ton per day, it is $11. So it is a very expensive business. And another interesting aspect, the Department of Energy in United States, they said they have a principle called 1-1-1. Those who are loving cricket, 1-1-1. If somebody is playing on a score of 1-1-1, he can get out. Unlucky guy. Nelson's eye, they call in cricket. Okay. 1-1-1 means 1 kg hydrogen in $1 in 1 decade, and that is 2031. At that time, US government is giving $3 per kg incentive to those who are making green hydrogen. So what our industry, I spoke like this in some seminars, and I said, our government is not doing anything. Now, very recently, our government said, 50 rupees, 40 rupees, 30 rupees, 50 rupees first year, 40 rupees next. I said, why are you not making 150 rupees? That's what my suggestion. Unless we produce green hydrogen in our country and make an exporting nation, because we have demand from Germany, Australia, Netherlands, 3 countries. They want hydrogen from India. So they said, you make it. Okay. So you see that. So this is otherwise cost of hydrogen is $2 to $2.5. Right now, what they sell in the laboratory, which you get is 900 rupees a kilo. Okay, but so what we did, we studied everything related to this. So this particular slide says what we did over the years in my laboratory. We coupled these problems. So what we said, we want green energy. So I need green energy. So I don't have solar energy. So we use molten salts. We store the energy in molten salt, then molten salt is used. We have this copper chlorine cycle, which is 6-day cycle. Everything is recycled. Water goes in, you get hydrogen and oxygen. Hydrogen can be used. So we did many things. Carbon dioxide to methane, because methane can be used. We used SNGs, carbon dioxide to methane plus hydrogen. Now that mixture can be anywhere between 10 to 20%. Okay, so we have that. That is so-called SNG. They are running those buses in in Delhi. So another is carbon dioxide to methanol, carbon dioxide to dimethyl ether, carbon dioxide to LPG. So carbon dioxide becomes a source of chemicals, materials, fuels for me. That is what I said in the beginning, carbon dioxide refinery. And other thing, dimethyl ether is a very good substitute for LPG. And the infrastructure is available. So we can mix dimethyl ether in LPG, use it. This calorific value increases. So you see that we can do many things with this. So we studied everything. We got several patents. So we studied biomass, studied plastics and whatnot. So another issue related to electrolyzers is the cost of electrolyzers. The statistics during 2020, I wrote a very big paper also that time. It says $1,100 US, but typically when I consulted the IOC, because I'm on their board, so we found that advisory board, I found that it is not less than $2,000. But actually, if the cost, if the hydrogen has to be economical, it has to be less than $150, typically $100. You can see how many stages are involved. So everywhere across the world, people are saying they have got green hydrogen. They don't have it. They're making tall claims because their stock value can go up. That is the reason. So yes, we can see that. So what we did, we compared, I compared this thing, table, all other things, whatever they are saying, the gold standard is green hydrogen, right? So steam refinery, if you use coal, it is 19 tons per ton of hydrogen. If you use gray hydrogen, natural gas, 11 tons. You see that entire thing. Blue hydrogen, turquoise hydrogen, turquoise hydrogen, 0. In our case, there is no carbon dioxide coming in the process. So it is a green hydrogen. So we compared that, and this is where I'm saying 95 cents. Remember, 1 ton of 1 kg of oxygen costs 15 cents American cents. So it gives me almost equal value. So I have that. So that is my buffer. So we calculated this. And very interestingly, this was mentioned by Honorable Nitin Gadkari in the Rajya Sabha last year, that Dr. Yadav has developed this because he has seen our plant, pilot plant. So it was a good news that somebody is promoting our work. And then, later on, we had this India Energy Week where the Prime Minister was also there, but he did not come to our plant. The minister came, other minister. We inaugurated that plant, this pilot plant, which we are running. You can see my students, they're still working there. And this ONGC chairman was also there. So, that was a good news. So that encourages us to transfer technology to industry. Now 3 companies are working with us where we are talking about methanol, dimethyl ether, methane. And so, so if there is no fuel, can carbon dioxide be the oil? And this already I told you what has happened. So you can see carbon dioxide refinery means I can make many, many things from carbon dioxide. But these are catalytic processes. So I require money. I require an ISOP catalyst. So in our case, we studied the catalyst 3,000 hours, nothing happens to that. We got patents on that. But you can see that carbon dioxide is going to be a future source. So we don't have to worry. And that is what I'm saying, that net negative for that reason only. And then, of course, you can do organic chemistry. I won't go into the details of this. But methanol, another important part. Our Niti Aayog is talking about methanol. So we are saying carbon dioxide to methanol, we can do it. We have developed technology. We have got patents also. And methanol can be used as a major feedstock for all sorts of chemicals. And so is the case with dimethyl ether. We can use dimethyl ether also. So remember, now we're shifting from carbon dioxide to methanol to dimethyl ether to methane and higher hydrocarbons and whatnot. So this is the way we talk about the integrated technology. We can integrate all these things at single site. So we have got this particular thing, and we are now, this is where people are participating with us. Expression of interest was shown by 3 companies and many, including foreign countries. They say that they are interested in this. Then we did carbon dioxide to dimethyl ether. This is with Godavari biorefinery because all fermenters generate carbon dioxide. So I said, Samir, why don't you be partner with us? And they agreed. And this was done by a postdoctoral work, the PDF, Kotari PDF. So they produced 300 tons. Now they are producing 500 tons of carbon dioxide. So you get carbon credit and also get valuable fuel. So carbon dioxide to methanol. Now we are building a 5 tons per day plant on this pilot plant. So this is also there. And so you see that, so when we don't have a crude oil, this is just comparing the petroleum refinery versus biorefinery. The left-hand side is a functionalization. Our basic feedstock in refinery is benzene, toluenes, oil, and butanes. That is my feedstock, and I can develop any chemical. Here the exactly opposite. I have to defunctionalize it. There are so many functional groups. And so this is where hydrogen plays a very important role. So I can have integrated biorefinery. I can have any sort of biomass I can integrate. Of course, it is going to be expensive because we are defunctionalizing. And there is an efficiency. So cellulose, hemicellulose, lignin, anything I can take and make chemicals. And one important part I tell you, so this is where, once again, if I say hydrogen, because hydrogen is ruling all these industries. That means green hydrogen is ruling. So green hydrogen, as I mentioned earlier, is going to be the savior of the world for that reason. That is what I'm saying again. So look at this, how many reactions I can do. And these are all catalytic. So cellulose, hemicellulose, lignin, all these become sources. And these chemicals from lignin, they are not less than $2, $3, $4, very expensive. Chemicals can instead of burning lignin, make chemicals and fuels, and so that your carbon dioxide emissions will not be there. That is what we have been saying. In fact, from cellulose, hemicellulose, we have this C5, 6 sugars. I can make any type of sugars, 6 different type of sugars. So I say jokingly, farmers need not grow sugarcane. I can give you sugar for making use of this cellulose, hemicellulose. So lignin I can be used like that. So we propose this in one of our papers, that how this is going to be very important, why hydrogen is important. Look at the top portion of that and bottom portion of that. Bottom portion is related to lignin, top is, the C5, C6 sugars and hemicellulose, cellulose, hemicellulose. I can make all sorts of chemicals from hydrogen and oxygen. So, and we know that during COVID time, we had problem of oxygen also. We had no oxygen supply, right? But this is what it is. So hydrogen and oxygen, that means water splitting. So now we understand that when the farmers are burning something, I'm telling you, don't burn it. We can give you more income by doing all these things. I can produce many, many things from this biomass. So then basic question is, now we have a policy of mixing ethanol or bioethanol into petrol, diesel. My idea is it is not a good idea. Why I'm saying so? Because we did calculations. We said, can we compare a crude refinery with that 97.4 million barrels I said against a biorefinery? That crude refinery gives me 1 kg of crude gives me 32 megajoules of energy plus 0.2 kg of chemicals. But if I take the biomass and go to biofuels, it does not give me more than 6 megajoules. But instead of that, it can give me 0.8 kg of chemicals. So then we compared this, okay, with the 97.4 million barrel. That is 215 barrel per second. That is what the current refinery, standard refinery. If you have 100% biomass, it gives only 10 barrels per second. So biofuel is a bad idea. And if you convert that biomass into chemicals, 320 barrels. So what is good? Making chemicals is better, common sense. And at the same time, biomass, but yeah, for next 4-5 years, maybe up to 2035, India can have that policy because we want to reduce the import. But beyond that, we should not be. We should make ethanol, go to ethylene, and I can have 11 different bulk chemicals or 30 different chemicals. That is going to be my source in future when there is no crude oil. So carbon should not be burned as a fuel. That is the mantra which I'm telling you, okay? And so another thing which I already told you of the plastic one, okay, what we can do. So it is the same thing. Plastic ban is a bad idea, I told you. So we can have this plastic recycling. Now, another interesting part, plastic you have to segregate, but you have a collection of plastic, you have everything in that. Maybe rubber is there, maybe polythene is there, polypropylene is there, PVC is there, polyurethane is there. That can be a very good source of hydrocarbons when I use hydrogenolysis or hydrogenation. And so if that is done, you can see that waste plastic recycling, chemical recycling techniques are better than putting plastic somewhere else or stopping usage of plastic. So you take the plastic, I can do chemolysis, we can do hydrolysis, I can do pyrolysis, I can do gasification, I can produce syngas and Fischer-Tropsch synthesis, I can do many things. So in other words, these processes give me better yield and better value. And another idea here that hydrogenation can handle mixed pack sheet. Other techniques cannot. You have to segregate. Polypropylene must be segregated from polyurethane. This is not so. Why it is so? Because all these reactions give me this mixture of hydrocarbons, different sections. So I get, and that is what I do in the refineries. I need hydrocarbons. So by using waste plastic, I can make hydrocarbons and also this variety of gases. The technology is already known, ammonia, H2S and all that, okay? So waste plastic is a better source of chemicals, hydrocarbons, and I can use anything. So this is what I'm trying to tell you. And another steel also I told you. Steel, this capacity I mentioned to you. So green steel, what they call, this is because, right now our problem is, I tell you what, we can produce hydrogen, where do we store it? Pressure. So, we have only type 2 cylinders, which is about 200 atmosphere. Now we are doing, because I'm chairing that committee, we are going for 350. We want to go for 700, 900 in future. But we don't have that carbon fiber. We have to import it. We don't have the resin which is required to make it. So you see that is a slow progress. But wherever it can be used in fertilizer industry immediately, or it can be directly used in refineries, current refineries, or steel industry, green steel. I told you already that 1 ton of steel produces 2.3 tons of carbon dioxide. Use this hydrogen, it will be green steel. Okay, so what is going to happen in the future? Future is that hydrogen will rule. People will accept hydrogen. Right now they are worried. What are they worried for? They think it is dangerous. They think hydrogen bomb. It is deuterium, not hydrogen. But that is what people believe, because people have all funny ideas. Many times they are. So acceptance by society, everything will be used where hydrogen will be used. And I must tell you, proclaim that hydrogen is safer than petrol and diesel. Simulations have shown that nothing is safe. Right? Now, for example, you are sitting below that. It can fall on your head. It will, yeah. So you are thinking it will not fall. So safety is like that. Safety is a professional hazard. Okay. So hydrogen is safer than conventional fluids, petrol, diesel, etc. Simulations have shown that although nothing is safe, when you go out of the home, motion. We deal with world of motion. So the goal for Vikasit Bharat, I'm saying this, I'm making some bold statement. So if we 2047, we want to have $30 trillion economy, we must have 25% growth in manufacturing sector. So some of the IIT students only go for CAC. They think other disciplines are useless. Nobody wants to do chemical engineering. I'm telling them, look at my slide, you will come back. Why are they saying that? Because it is glamorous. 3 IITs where I went, they asked me to address the students. They said, there is no interest for students in chemical engineering. I said, why? Maybe you are not telling them properly. So I said, take this mobile phone. This mobile phone contains 30 inorganic chemicals. It contains the glass, so-called smart, touch screen. It is indium oxide. Go inside your carbonates, polycarbonates, your silicon, your gallium arsenide, you have all the chips, you have all the resins. They all come from chemical and allied industry. So if you want to run your 5G, 6G, whatever, you require those materials, right? Those materials have to be there. And if they are not there, where are you going to run your computer and make? So, I think we have to tell the student the reality. So this in that regard, I'm saying this. So 24%, 25%, service sector 70%. And I'm saying this boldly, I have said it many times, including ministers, central ministers. Corporate social responsibility should be 3%, not 2%. That 1% should be given to higher education for doing research, innovation, and developing technology. And under this ANRF, Anusandhan Research, National Research Foundation, you are supposed to have industry's partner. Industry will not give you money. Nobody gives free money. unless they want something. So why not share technology with them? Correct? So that is where that extra 1% will be useful. Believe me, even IITs will find it difficult to get funds in future. So this 1% extra can be used for research and innovation technology development. And in that, I'm saying 0.2% should be used. I call this scheme as a SIR, sir, Students Internship Responsibility. All students must have internship, summer training, whether it is 6 months, 1 year, 2 years, all of them must be given and they must be paid also. Not free, nothing free is appreciated. Otherwise, they will come on the first day, last day, they will come take the certificate and go home. You are happy, he is happy. He has got a certificate, he worked in the industry. No, SIR. So I told this the government, I said, make this. This is very important. 5,000 minimum. Give 5,000 per month. Students will work because they are bright, they are enthusiastic, and they will be kept occupied. And I'm also making one statement, free education to girls. Now, girls should at least clap, I'm saying on your behalf. Why I'm saying that? I'll tell you, this is social engineering. Because if girls are given free education, whether they are rich or poor, billionaires, whatnot, they will have an avenue to go to the next scale. So they will not stop in 10th or 12th or bachelor's or master's. Of course, there is a gradation. Those who are capable, they will go for master's or PhD. But they will not be required. Their parents will not stop them. So they will not get married early. Their marriageable age will go up. Correct? Population will come down. And educated mothers will never have more than 1 or 2 kids, sometimes 0 kids. Correct? That is the way. So it's a social engineering. And 2 generations, India will be a great country. That is my personal belief. That is my personal belief. You may disagree with me. Then that net zero, whatever we are saying, we want to be number 2 economy in the world or number 3, that is all possible provided our lady folks, because India is traditionally unfair to girls. They are unfair. Parents are unfair. Well, paraya dhan hai, jao. Husband will teach or your in-laws will take care of you. So this is my personal belief. Okay. So ultimately, I will end my lecture by quoting Swami Vivekananda ji, that each work has to pass through 3 stages. You are ridiculed first, then there is opposition, and last is acceptance. That has happened with many things, whether it was X-rays or the so-called MRI. MRI is an MRI, nuclear magnetic. That nuclear was dropped so that society accepts that technique, right? So, ladies and gentlemen, then only we'll have the so-called green economy, and then, so the net negative goal is important. I told you, green hydrogen, carbon dioxide, waste biomass, sustainability, all these things are then possible. And we in India can make it. Indians are very smart. Nobody is going to give us technology, believe me. We have to develop our own technology. So ladies and gentlemen, thank you so much for listening to me, and we're more than happy to answer any questions. And I deliberately removed all equations and chemistry so that, because I know it's a general audience.
So thank you, Professor Yadav, for a wonderful talk. So, floor is open for any questions. Maybe I will get started.
Yeah, please.
Gasification route. So as per the policy, as I understand, in India, that is also
Yeah, it is being promoted. It is promoted.
So what is your opinion about that?
I tell you, it is net zero. Biomass is net zero. It is not net negative. But we can produce hydrogen. We can produce hydrogen. Yeah, that is there. Government wants farmers to benefit. So when you don't have many things, at least you start with something. But in the future, they will abandon it. But now, yes, net zero is okay. But I said net negative. We have to have, hydrogen, green hydrogen is the savior. But even in 2050, we will have both blue hydrogen and green hydrogen. That carbon dioxide has to be captured. No? So what they do normally, those who have, depleted oil wells, you pump that carbon dioxide into the wells, produce more oil, store that carbon dioxide, but that is not the end of the world. You have to use that carbon dioxide, so-called CCUS, carbon capture, utilization, and storage. I'm saying not storage, but convert that into all these things, whether methanol, dimethyl ether, LPG, whatever. That is what is going to happen. But yes, government wants to promote because it's an approach to save money, foreign exchange. We have to save foreign exchange. So that policy is right now, but not in the future. Like, as I said, in the future, it's not a good idea. Like bioethanol is good right now because we are reducing the import and farmers are getting money for that. But in the long run, it is not. Yeah, please.
Solar at, solar rooftop, decentralization.
Yeah.
It's somewhere that, homes with sort of hydrogen production, storage. And so is it feasible? That means, at particularly in villages and all that,
No, I'll tell you. No. That decentralization is a good idea, solar energy and all. But I'm telling you, this solar energy also. Now I'm telling you, I'm sitting on the other side, on government side. What we realize that it requires tremendous land. And getting land in our country is very litigious. People don't give, even the Mumbai, Ahmedabad road, you use the railway track, super fast train, bullet train, so many. So was the case with that Samruddhi Mahamarga. So getting land is difficult. But so I said, why? Who said that you should do it only on that? Railways have a lot of land. Our land is defense, railway, and the third is work board, right? Sorry, I don't want to go into politics, but railway, we can use that for solar energy or even floating panels. Floating panels. Yes, but hydrogen making in the kitchen, those days are not there yet. Okay. But you use solar energy, solar energy, and also wind plus solar, this combination is available now, where the efficiency of the solar panel only 6 to 7 hours is about 85%. Wind is 15%. But now somebody in Netherlands has developed a much better, superior model for combination of solar and wind. That is going to replace, believe me, so many things are happening as far as the technology is concerned. Everybody wants to be in the market the very next day. But for farmers, best is to collect all these, biomass, compact it, make it compact, pelletize it, densify, pelletify, and then send it somewhere else where you can make these chemicals materials on. Or you have biogas. Okay, biogas is methane plus carbon dioxide. Some methane, sometimes COS and all the things are there. That biomass, so what we did, we took biomass and increased its calorific value by doing hydrogenation, right? So we can do that. And we can make SNG out of that. So, yes. So, and then you get fertilizer. So it becomes a part of circular economy. So that is carbon neutral. It is, whenever there is biomass, it is carbon neutral. It is not carbon negative. So majority of things for bringing down the 10 billion tons per annum CO2 emissions, we have to have carbon negative sources, energy sources. That carbon should be used for chemicals, materials, etc., which is required, right? Yeah, please.
One particular slide, you talked about 1 kg crude. 1 kg crude will produce 0.2 kg chemicals, and 1 kg biomass will produce 0.8 kg chemicals. So why people are so interested in crude to chemicals?
Oh, very good question. Because right now crude is available at a cheap rate. It is economics which decides it. I teach a course called Green Chemistry and Engineering to students. So I tell them jokingly, the Shedji is not interested in green. He is interested in dollars. More dollars green you get, you may develop and use any technology. But incidentally, as engineers and designers, we have to see that it doesn't pollute also. So right now, why they are? Because it is cheap, no, to use. The refineries are designed and they are there, millions of tons. Now I gave you a number also, 103.498 barrels per day, million barrels per day they are processing. And this is where hydrogen is again required. But for future, I'm saying that that is a bad idea. Biomass should not be, burned. Biomass should be used for making chemicals. And once again, their molecular weight is increasing, right? So that is because of hydrogenation or oxidation for that matter.
Thank you, sir.
Talking about storage of hydrogen, in that we are talking about. Sorry, sir. When we are talking about hydrogen storage, in that case, we are talking about synthesis of ammonia from hydrogen using nitrogen sequestration and all. So, but that again, cracking ammonia is a.
No, very good question. When man started motorcycle, it was cycle, right? You start with something. So what they say, Germany and other Nordic countries, you have green hydrogen, convert that into ammonia, carry that ammonia. So ammonia can be stored at 10 atmosphere. Hydrogen requires very high pressure. So material of construction, because there is a problem with that high content of hydrogen. So ammonia can be used for anything where even fuel cell. Ammonia can be used for fuel cell. Ammonia can be used in boilers. Ammonia can be used in IC engines. But when you use it in IC engine, it becomes NOx, right? So you have to have another catalytic process there where the NOx becomes nitrogen. So that means you have to have some hydrogen there, right? So instead of that, they say you make ammonia at the site of application, you dissociate it, make nitrogen and hydrogen. So best stage is use that nitrogen again, use that hydrogen for any other sources you want. Okay, that is what the storage purposes. Right now, the technology is being developed. Okay, that is technology being developed. But till that time, most of the European nations are accepting ammonia as an energy carrier because it contains hydrogen. That is the reason. Yeah, yes, Professor.
You talked about this 2047 vision. Now, with regard to that, first of all, there is a lot of infrastructure development that is taking place, particularly the cement and the steel industry. They will emit a lot of carbon dioxide. So what is your view and assessment for the overall planning?
Yeah, very good question. What are they doing in cement industries? Now they are using biomass, briquettes, plastic and everything as a source of energy because they say by that way, reduce pollution, get energy. But that is not the solution. One of the solutions, because you are from atomic energy should have been promoted. That is a big mistake we have been. Atomic energy is a carbon-free energy. And when I was in USA for swearing in of my, US National Academy of Engineering, I met President Obama was advisor. And you know what he said? United States government did a very big mistake by not promoting atomic energy. Germany did the same thing. They closed their atomic energy plant. They closed their coal power plants. And you know what they told us? And our people in down south, near your IGCAR, they used to have demonstrations. We had 25 projects with you. So I used to go there. You know what interesting part? The people used to go and demonstrate without knowing for what they are coming here. Because they were given 500 rupees, khana, just take the placard and say this is bad. They said Germany has stopped. Only France is doing it. That's what they used to say. Now what happened? Germany restarted their nuclear power plant. Germany restarted their coal-fired power plant. Why? Because they have no energy. So giving bhashan and giving advice to developing nations like India is very easy. That is what most of these advanced nations do. That they think that we are irresponsible. How can we have atom bomb? So that is the philosophy. Many people don't realize atomic energy is a very good solution for decarbonization, and it should be promoted. Apart from that, all other places, these other renewable sources, solar, wind, and all. So I have a solution. Like supposing there was a universal grid with 1100 volt, okay, 1100 volt. That runs across the world. Sun is there every time somewhere. We can generate energy that can go into the grid and we can make use of that. But then it is international politics. International politics. So universal grid is one of the best solutions for energy shortage. And in future, now we are talking about fission and fusion and whatnot. Fusion also you require hydrogen. So without that you cannot do it. So you see, as far as renewable energy is concerned, there are many solutions, but economics governs everything. Economics governs everything. And somewhere government has to give subsidy to promote that industry. Like this, for example, this mobile phone, when they introduced, I still remember Sunil Gavaskar coming on TV and showing mobile phone, some cricket match. How many people had mobile phone? Hardly anybody had mobile, right? Owning a mobile phone was a prestige. Now everybody has a mobile phone, 2, 3, sometimes 3. I don't know what people do with 3 mobile phones. Maybe one for boyfriend, another for mother. I don't know, but that material use has gone up, energy use has gone up. That is what is going to happen. This energy requirement of the world, right now our models, what they predict is not going to happen. It will be totally different. Okay? Totally different. Because we are dependent on electrons, electronic things, right? Gadgetry, sensors, and whatnot.
Yeah, maybe one last question in the interest of time. Yeah.
Yes, he was my student. Rucha, okay.
Hello, sir.
Yeah.
Sir, the CO2 to methanol and other chemicals, will it be comparable with the market price of chemicals?
Very good question. I tell you what is happening these days. When you take natural gas and make syngas, carbon monoxide and hydrogen, from that normally they prepare methanol. That cost of methanol is 25 rupees a kilo. So if I am producing hydrogen and then using that for carbon dioxide, my cost of methanol will be higher. Depends on the scale. But to protect the environment, that is the best solution. To protect the environment, that is the best solution. Cost will depend on the scale of operation and the cost of hydrogen.
Okay, I'm sure there are more questions, but maybe in the interest of time, we will conclude. So I again, on behalf of COE, OG and INAE, I thank Professor Yadav for sparing his time and this wonderful talk. I'm sure all of us got inspired. Again, thank you very much for coming. We'll conclude the session and let's thank Professor Yadav once again.